Welcome to completing the square. Why do we do this? How do you do it? Well, it starts with a quadratic equation. A quadratic equation looks like ax squared plus bx plus c equals 0. Now, we want to make this thing look like that. Why? Because if it looks like this, then we know the solutions are going to be x equals plus or minus the square root of c. So if you actually subtract this c over, you will see that you have an x squared term, just like over here, but the coefficient is 1. You don't have a linear term, but you have a constant, and here you have a constant. So we're really trying to make this thing look like something squared equal to a constant. So let's say we have x squared plus 6x plus 9, and you want to factor this. Well, we know our first terms have to multiply to give us x squared. When we multiply our outers and we add those to the product of the inners, we've got to get 6x, and then our last have to give us 9. So you can see that your choices are x plus 3, which we will write as x plus 3 squared. We can do the same thing with x squared plus 4x plus 4. We can see that that factors into x plus 2 squared. And then there's something that you can notice from this number and that number in relationship to this number and this number. If you look at this number, it's half of 6, and this number is half of 2. But then what is the relationship? Half of 6, you get 3, and then what is the relationship between 3 and 9? Well, 9 is 3 squared. And this is half of 2, and 2 squared will give us the 4. And you can continue playing with these type of things and you'll see the pattern unveil. But what we're looking at is if you take half of the middle term, so if you have x squared plus bx, and you take half of this middle term, so we'll call that b over 2. That's our magic number. And you square that, b squared over 4, it will always factor into x plus b over 2 all squared. So this is the key that we use to complete the square. Is you're going to make sure that in your equation, whichever equation you're going to solve, that you first put it in standard form. So let's say if you have x squared plus 6x minus 2 equals 0. Well, this is already in standard form. Okay, so standard form is ax squared plus bx plus c. And then you want to make sure that the coefficient of your square term is 1. Okay, so we know that 1x squared is the same thing as x squared, so we're good here. Now, once you have that, you're really just going to play with this part. So you're going to need to move your constant over to the other side. So let's add this 2 over here. So we have x squared plus 6x. I'm going to leave a blank, and I'm going to put my 2 over there. Why leave a blank? Because you saw that from before we're going to add something in here. Well, just like in the previous example, we said the number that you would add here was 9. We took half of the 6, which is 3. I'm going to write that off to the side and put a circle. That's my magic number. Now I'm going to square that and add it in. But we know with an equation, if you add something to the left side, you need to also add it to the right side so that you don't change the value. And then we see that the left side factors into this. Well, look, the magic number just goes right there. So then you have 11. Why is this great? Because now we can see that you have this form, something squared equals a constant. So if this thing squared equals a constant, then we know that that thing, which is x plus 3, is just going to be equal to plus or minus the square root of that number. So plus or minus the square root of 11. And we want to know what x is, so if we subtract 3, we get this number, -3 plus or minus the square root of 11. Well, some students don't really understand what that means. So this little plus or minus is really just a compact way of writing positive square root of c and minus square root of c. So if we were to pull this apart, you would have the minus and this. These are called exact answers because they have a radical which represents all of the decimal places that the square root of 11 contains. If you want to know the approximate value, you can put this in your calculator and that in your calculator. And these are just two numbers. Now, what if the coefficient of the x squared term is not already 1? Well, we'll make it a 1. 3x squared minus 5x plus 1 equals 0. Here's another example. This one is in standard form, but we have this 3. So before we can complete the square, we need to do something with that. We need to turn that 3 into a 1. So you can go through and divide every term of the equation by the same number, and 3 divided by 3 will be 1. So from here you will have x squared minus 5/3 x plus 1/3, and 0 divided by 3 is 0. So really, we're going to complete the square with this version. So we're going to finish up the same way. We just need this part. So you're going to move your 1/3 over. So you have x squared minus 5/3 x, you leave a blank, minus 1/3. Now what number are you going to add in there? You're going to add half of -5/3 all squared. So what is 1/2 of -5/3? Well, that's just going to be -5 5/6. So this is my little magic number. I'm going to put it in a circle. That's not the number that you add in. You add in this thing squared. So we're actually going to add in 25 over 36. Okay, so you add that to both sides. And then we know that the left side factors into x, and then you put your magic number there. And -1/3 plus 25 over 36 comes out to 13 over 36. So this one is all fun because it's got lots of fractions in it. But we now have this form, something squared equals a number. So we can take that something and set it equal to plus or minus the square root of 13 over 36. And then you add your 5/6 over. Now the square root of 13 cannot be simplified, but the square root of 36 is just 6. And so really what we have here is 5 plus the square root of 13 over 6, and 5 minus the square root of 13 over 6.